there is a method that allows you to use the components to find the cross product. But you have to put the vectors into a matrix. Now, let's see what other problems are on here. Yeah, that would be especially useful for these types of problems where the vectors are given in component form. So let me show how to do that. So this vector A would be 4 comma 0 comma 0 if you were to write it as a 3 component vector. And then for this one we'd have negative 4 0 0. And you want to have all 3 components to do this because it is a 3-dimensional type of operation ultimately. Alright, now the way it works is you have to set up a matrix here where you have your I on the left, the J in the middle, and K hat on the right. And then that's what goes in the first row. In the second row, you put your first vector of the cross product. So see, A goes in the second row. And then B goes in the third row. So we're going to have 4, 0, 0. And then negative 4, 0, 0. What you have to do is you have to multiply all the forward diagonals. The first one to do would be just the I times the second component of A and the third component of B. But there's actually more to do. You have to do 3 forward diagonals. And so what I often recommend is to take everything that you have and just repeat it outside the matrix. And you do that on the right and on the left too. Alright, then you can find your next diagonals. See? Now some people do it where they kind of wrap around to the other side. I just feel like this one's a little bit visually easier to understand what we're doing. So you multiply all of them. Alright, what would that make? 0 times 0 times I hat for the first diagonal. And then you'd have 0 times negative 4 times, that's a J, times J hat. And then you add the results, see? 4 times 0 times K hat. Great. But believe it or not, it's not done because you got to do the backwards diagonals too. And so we go this way now. And we just got to do 3 of them. But the backwards diagonals get subtracted. Alright, you sum all that up. You could actually see that this one's going to be 0. You know, every product is 0. So the cross product is 0 for that one. And that's the answer. Alright, I'll try it for number 2. Here for number 2, we actually will get an answer that's not 0. Alright. Put I, J, and K at the top. Put vector A in row 2 because we're finding A cross B. A will be 3, 4, 0. B is 5, 0, 0. We'll just repeat those numbers. So that we can easily make our diagonals. Now we'll go with that forward diagonal plus that forward diagonal plus that forward diagonal. So that's going to be 4 times 0 I plus 0 times 5 J plus 3 times 0 K. Now we'll do our backward diagonals. And we'll subtract those. 0, 0 I, 0, 3 J, 5, 4 K. Alright, so this is just 0, 0, 0, 0, 0. Okay. Negative 20 K hat. And that's the answer to the cross product. A cross B. And you can check the direction just using your your pointer finger and middle finger. You'll see that the direction's correct. Your thumb would point into the page if you did that. And then what about the magnitude of it? Like, is that correct? Let's see. Yeah, we would want the area of this parallelogram here to be the magnitude. And it is 20 because you got a height here of, looks like 4. And then you got this base, which would be 5. So yeah, 4 times 5 makes 20. It's correct.